Welcome to GT online course. Today's course is LTE interference analysis and troubleshooting. First, we can see the content. Today, we will learn about three topics. First is the overview of FDD LTE interference. Second, about FDD LTE intra-rat interference. The last about FDD LTE inter-rat interference. Okay, first we can see the overview of the interference. So what is interference for LTE? The interference means there are some unweighted signal with the same frequency to the used signal, so that this will cause the used frequency signal has some problem, such as this cell access failure. It means this interference will affect the access indicators, will cause access indicator KPI lower. Also will cause the call job. The call job indicator will become higher, and also this will affect the handover. This interference will cause the low handover successful rate. Also, this interference will cause the low service rate, affect the throughput. And if you use VoLTE, the VoLTE is also very sensitive to the interference. If one cell, the interference has big problem, then if you make a VoLTE voice phone call in this cell, of course, the voice quality will be very poor. So this is the interference overview. And about FDD LTE interference, there are two types. First, it's intra-rat. Second is inter-rat. So what is rat? Rat means radio access technology. Intra-rat, that means the interference of LTE is also come from LTE. So this we call it intra-rat. Inter-rat, of course, that means the interference of LTE is not come from LTE. Maybe it's come from 2G, 3G, or maybe it's come from other wireless technology. So first we see the intra-rat interference. About learning the intra-rat interference, first you need to be clear about the downlink interference and the uplink interference. So when we analyze about interference, we need to analyze these 2 points separately, downlink and uplink. In this page, it is talking about the downlink interference. So first, I will show you the principle of the downlink intra-rat interference. So now let's suppose this is one side, this is the other side. One side, this is one cell, this is the other cell. This is cell 1, and this is cell 2. Okay, and this is UE. UE is here. UE is now UE select cell 1, and the UE make access to the cell 1. So UE traffic signal is from cell 1. So this is cell 1 useful signal. So this is signal. And because UE is also close to cell 2, so that UE can also receive the signal of cell 2. But this signal for that UE is not a useful signal. It's the interference. Interference. Okay. And how this UE take a measurement for this interference? Okay, actually it is by one reference signal. This signal we call it a CRS. CRS, C means cell, RS means reference signal. In LTE, as we know that if the cell is open, then the cell will periodically transfer CRS signal to the UE. This is the downlink reference signal. Then UE will receive this signal. Then UE will take a measurement. First, the UE. For example, for UE, cell 1 is serving cell. So first, the UE will take a measurement of the RSRP. RSRP, that means reference signal receiving power. RSRP for this UE. That means UE detect the receiving power level of cell 1. Actually, this power means the CRS receiving power. Also, this UE will take a measurement of the signal. So, what is the signal? Signal, that means is RSRP minus interference. Okay, I use I for short. This is signal. RSRP is the serving cell signal, and minus the RSRP minus interference, that is the signal. So the interference is means this mainly about the signal from other cells. So for this UE, that is the interference. And this signal will affect something. For example, UE will take a measurement of this signal, and then according to signal, UE will report a CQI channel quality indicator to the cell. CQI is transferring the CSI. So that means if UE detect the signal is higher, then UE will transfer CQI level higher. So when the InnoB receives the CQI, the InnoB will make the scheduling from CQI mapping to the MCS. MCS is mean modulation and coding. So it's very clear that if the downlink UE detect the serving cell downlink signal is good, then the CQI is higher, MCS higher, then the UE throughput will be higher. Otherwise, throughput will be lower. Okay? So you can see this will affect the throughput. And also, if the downlink interference is very higher, also affect access. Okay? And if you want to know about the downlink performance, such as the RSRP and signal, you cannot directly see it in the EMS. Usually, you need a drive test to see this performance. Okay. So that we know this downlink interference will affect the performance, and how to make the optimization. And usually, this downlink interference optimization, we will do this in the coverage optimization. In the coverage optimization, we will try to avoid the overlapped coverage, overshot coverage. So what is overlapped coverage? For example, like these two cells has a lot of overlapped area. This is not so good. Okay. When we make 12 tests, we can see this. Then we can change the antenna azimuth or change the antenna down tilt to solve this problem. So it's very clear that the downlink interference we can see in the gel test, and then we will solve this by control the coverage. Okay, so this is about the downlink interference. And about the uplink interference, first, you need to be clear about what is the uplink interference. Same, this is one side. For example, this is the other side. This is one cell. This is the other cell. This is UE. UE select cell 1. Cell 2 is neighbor cell. And then when UE is go to the RC connected state, then UE will access in the cell 1. Then if UE will transfer the signals or transfer the traffic, UE will send uplink. UE send uplink to the cell 1. But as we all know that UE antenna cannot support directional. UE antenna is omnidirectional. It means actually UE will send this energy to all the directions. Of course, this will also send to the neighbor cell. Okay, so it's very clear. This signal for cell 1 is useful signal, but for cell 2, this signal is not useful signal. It's interference. So, as you can see, that this is the principle of intra-red uplink interference. Okay. So it's very clear how to solve this problem if you have this problem. Similar with the downlink. Usually, when we control the downlink coverage, so the problem of the overlapped and oversold coverage, it is also helpful for the uplink. Okay. And for the uplink interference, even there is no interference because there are some noise. Still, there is a basic value. According to this page, the basic value is minus 116.2 dBm per RB. So it means the noise for every RB is this value. Okay. So for the uplink interference, how we know this? Okay, the uplink interference, we can get this KPI in the EMS. In the EMS, you can go to the performance window. Then there's a performance about the NI. Then you can see this KPI. And this NI is about it means noise per RB. Noise per RB. And we know that the lowest is this one. This we can see that this is about background. That means if you see the noise per RB is lower than this, that means there is no interference. If it's from this value to this value, usually we also no need to care. It's normal. But if the interference, the noise per RB value is from this minus 110 to minus 100, then the interference is higher. It's high. You need to solve this problem. If higher than minus 100, the interference is very high. Affect the performance. Okay, so the uplink interference, we can easily see this in the EMS. Okay, and how to make the troubleshooting for the uplink interference? Actually, it's very clear that the uplink interference is for the intra-red. Okay, later we will learn the inter-red. For the intra-red, there are mainly about two reasons. First is about the hardware fault. Hardware fault is mainly about the RU failures or antenna and feeder system failures. Because RU failure will also cause the NI value of normal. This one you can easily in the EMS, you can check the alarm in the EMS and check the RU log to see this, analyze this. Okay. Antenna and feeder system failures, this one you need to this one, if you want to confirm, then you need to check the hardware. Go to site, check the hardware to see. So first is the hardware fault, and the second is most widely seen in the network is the interference from the neighbor cells. And how to see this? I told you that the uplink interference, we can easily see this in the EMS. In the EMS, you can see the NI, means the noise. And if you in the noise, you can see the noise curve. If you see this curve is like this, RB0 to RB99, the two ends is high, or 1/3 here is high. Then probably this uplink interference is come from the neighbor cell intra-rat. Okay. And if you see this problem, actually, if the interference is not so high, it's normal. No need to solve this problem. But if the interference is very high, then you need to solve this problem. Okay. And how to solve this problem? Usually there are two methods. First, I told you, you control the downlink interference by solve the problem of overlapped or overshot coverage. Is also helpful to the uplink. First, and the second, the interference from the neighbor cell is very high. Probably the other reason is because the neighbor cell transmit power is very high. Uplink power is very high. So that you can try to enable. You can see if the neighbor cell enable the closed loop power control. If disabled, you can try to enable. Or you can see that if the neighbor cell the power P0 power of PU-SCH or PU-CCH, if it's very high, you can try to reduce to solve this problem. Okay. And also there are some other methods. For example, you can see this. This is a PD-CCH power and the CCE aggregation adaptive adjustment. This one was a meaning. As we all know that the downlink PD-SCH channel can support AMC. That means adaptive modulation and coding. But PD-CCH cannot support AMC because PD-CCH modulation and coding is fixed. But PD-CCH can support adaptive CCE. CCE has different AGG. Can support from 1, 2, 4, or 8. 1 is for good coverage. 8 is for the worst coverage. 8 means CCE will repeat 8 times. And this one can be adaptive. And the adaptive is based on the uplink HARQ feedback. So this CCE adaptive, it is good for the PD-CCH performance. And also there's a supercell solution. Actually, for the supercell solution, the solution means we can combine multiple physical cell into one logical cell. That is supercell. So that if we combine this, then these multiple cells will become one logical cell. Then before the interference will become the usable signal. This is supercell solution. Of course, you use supercell you can reduce the uplink interference. But remember, if you use supercell, then it's not good for the network capacity. For example, before you have 2 cells, then the capacity is the capacity of 2 cells, but you combine to 1 cell. Now you only have 1 cell. Okay, so enable supercell is good for reduce the interference, but not good for the capacity. So that supercell is usually used in the following scenarios, such as the Q cell indoor coverage solution. You can, if you use Q cell, usually we use this solution to reduce the interference. And also, there are some place it is outdoor macro cell, but it's very high interference. You can also think about this solution. The third scenario is about high-speed railway coverage. But high-speed railway coverage, we use supercell is not for the reason of interference. It is for the reason of the handover. We use this to make the handovers slower. Okay. So now we all learn the interference about the. Now we see the last topic about FDD LTE inter-rat interference. About the inter-rat interference to LTE is mainly about the uplink interference, because usually this inter-rat will not affect the downlink. So of course, and how to see this problem? The same with the intra-rat. We also see this problem in the EMS NI performance. And in the EMS NI performance, we can open this to see the performance, then we will see this problem. And you can see, for example, you can see this curve. From this curve, you can see that there are different cells, different cell noise performance. But for this different cell noise performance, you can see there are some peaks, interference peaks. But for these interference peaks, for different cells, the RB location almost the same. Then the problem is mainly about the inter-rat interference, because this interference for these cells have the same source. Or you can also see this curve. This curve is about interference with the time. If you see these 3 cells, you can see these 3 cells. When you see this curve, you can see these 3 cells, the peak of the interference of the time is almost the same. Then we can also think about the interference is come from the inter-rat. It's also because they have the same interference source. Okay, and after we confirm that the interference is mainly come from the inter-rat, and then we need to try to locate this problem and try to find out where is the interference source. And how to do this? First, we can use some tools, some software, some like GTE, we have the CNO, this software. Using this software, we can load the parameters and load the parameters of the EMS and the location. Then we can see which, from this map, we can see which cell has the interference problem. Then first we can locate this area. And after we locate this area, then we can go to this area to use some tools. These tools, we call it a frequency swap generator. This generator connection is like this. Antenna connect to this frequency filter and connect to this analyzer. Using this analyzer, using this and this antenna, we can find out where is the source. We can find the direction and we can find the location of this interference source. And after we find out the source, then we need to confirm if the problem is come from this source. And usually this source is 2G or 3G system. Maybe it's from same operator. Maybe it's from the different operator. If from the same, for example, is we analyze China Mobile and this source is also China Mobile. Then usually we can make some test. We can power off the source system. If we power off, then we see the interference disappear. Then we confirm. But if this source is come from the other operator, probably it's very difficult to ask them to power off. Then you can think about, for example, add some metal mask, or try to change our antenna azimuth to try to far away from the interference, and then we can try if the on the EMS the performance of interference change or not, to make sure. Okay, now you can see here, show you some examples. First, this example is about DCS 1.8. DCS 1.8 is GSM. This frequency maybe has the interference to FDD LTE 1.8. Of course, these two systems will using different frequency, but DCS 1.8 have the maybe will have the intermodulation effect. This effect is third order. Third order is 2F1 minus F2. And maybe this point will be in our band. You can see this interference. Okay. You can see this example. After we power off, disappear. And also GSM 900. GSM 900 also maybe will have interference second order to FDD 1.8. This second order. Okay, this example. Okay. So the last, if there are some inter-rat interference, and how to solve this problem. Actually, at the beginning, you need to think about this. You need to be clear that on your antenna and the feeder system. For example, if there are multiple antennas and feeder systems on the same tower, you need to think about this. You need to know that on this tower, you have the antenna and the feeder system from how many operator and using which frequency. You need to increase the isolation. You can use, for example, a vertical isolation to solve this problem. So the mainly method to solve this problem is to increase the interference isolation. Okay. So this is the end of this course. Thank you for learning.